Hey guys, this is Riya Soni and welcome to the DevOps Pro English channel. In the last video, we saw how to set up an AWS account and also created a user so that we can provision resources on AWS using Terraform. So assuming you have already done these two tasks, because today's video is going to be quite practical. Today we will provision a server using Terraform, okay? Let's see how we would manually provision this server if we had to. So to manually provision a server, we need to know two things. First, on which cloud we want to create the server. Cloud means AWS, Azure, GCP, Oracle, etc. Let's say for now we want to use AWS. The second thing is what is the name of the server on AWS in their terms, because each cloud has its own names for the servers. Let's keep it simple for now and understand that provisioning a server on AWS means creating an EC2 instance. Got it? So we have our answers now. We want to use AWS cloud and we need to create an EC2 instance on it. Now, when you go to manually create a server on AWS, let's see the steps you will take. First and foremost, you need to have an AWS account, which we set up in the last video. The second most important thing is that you will have to log in to AWS to create the server. Now, some of you might think why we are discussing such basic things, but please bear with me and pay attention, as understanding these steps will help you grasp how to do it with Terraform easily. Alright? So the second step is to log in, and in the third step you will search for EC2 and launch your instance by providing the necessary configurations. The first two steps are quite simple and we can easily do them. Now let's talk about step 3. So once on AWS, let me show you how to manually create a server. First, you need to search for EC2 on AWS console, and then you will see instances on the left side. Click on that. Here you might notice that there are no instances created yet. To create one, click on Launch Instances. Now you will have to provide a lot of information. Firstly, you will see the name field, so let's give it a name like manual_EC2. Next, you will choose the operating system image. There are different operating system images available here, such as Amazon Linux, Mac OS, Ubuntu, Windows, Red Hat, and many more. For now, let's choose Ubuntu. You can choose any operating system, but remember, it should be eligible for the free tier. For example, in Ubuntu, we see that both Ubuntu images are available for the free tier. If you look in the Mac OS, there are no eligible option for the free tier. So if you use any service outside the free tier, you will have to pay extra charges to AWS. For now, I will choose Ubuntu, specifically Ubuntu 22.04 LTS. In the next field, the instance type, there is only T2 micro available. So we will stick with that. For the key pair, we will proceed without a key pair and keep the rest of configuration as default. Then we will click on Launch Instance to proceed. Now, let's wait for the instance to finish launching. As soon as it successfully launches, you can click on the instance ID to view it. Our first instance has entered the running state. So far, we have learned how to manually launch an instance and what configuration we need to provide. Now, it's time to provision this server using Terraform. The most important thing that I always emphasize is that we don't need to remember everything. We should always refer to the documentation and practice as much as possible. Alright, currently I am on the website registry.terraform.io, where we can see various platforms like AWS, Azure, GCP, Alibaba Cloud, and many others, which we also saw in the last video. Terraform supports all these platforms, and in the Terraform's terms, they are called providers. Just like I mentioned at the beginning of the video that if you want to create a server, you should know on which cloud you want to do it. Similarly, in Terraform terms, if you want to create a server on AWS, you need to use the AWS provider. These providers are like which platform you want to create services on, and you can select the provider accordingly from here. Besides providers, you can see tiers here. Terraform has 3 tiers, which means it supports 3 types of providers. The first is the official provider, which is directly managed by HashiCorp. That's why the chances of errors in these providers are minimal as they are always up to date. The second type is partner providers managed and maintained by technology company partnering with HashiCorp. And the last one is community providers, where individual users create and publish their providers. And hence, they might not be able to maintain the code all the time. So if you use these providers, you might encounter errors. That's why for production use case, we should mostly use official providers. Now, since we want to launch an instance on AWS Cloud, we will click on AWS Provider. Here on the left, you can see the AWS Provider's download count for the last week, last month, and how many users are using it. Now, if you want to use the AWS Provider, click on the Use Provider. Here, you will see how you can write the AWS Provider in Terraform. First of all, you can see here Terraform 0.13 plus, which means the syntax shown here is applicable for version 0.13 or any version above it. I should mention that at the time of video recording, the latest version of Terraform is 1.5.3, which was released just a few days ago on July 12, 2023. So in our case, the syntax for writing the AWS provider in Terraform will remain the same. Now let's copy this code and move to VS Code. There I will explain what's happening in this code. In this script, we are first setting up Terraform configuration. Next, we specify the required provider, which is AWS in this case. If we were using a different provider like Oracle or others, we would replace AWS with its respective name. Inside AWS, we have a source called HashiCorp/AWS. This indicates where to install the AWS provider for Terraform. HashiCorp is the namespace and AWS is the name of the provider. AWS is an official provider managed directly by HashiCorp, hence the HashiCorp is the namespace. You can identify this from the provider's URLs, where it's written as HashiCorp/AWS. Similarly, if you check the Azure provider, the namespace will be HashiCorp/AzureRM. And for Oracle, it will be Oracle/OCI. The source helps us to identify official providers. The next part is the version, which is 5.10.0. This is the latest version of the AWS provider. You can find the latest version in the documentation to determine which version to use for your Terraform code. In production, it is advisable to specify a specific version to use. So far, we have discussed Terraform configuration and the AWS provider block, which is necessary to install the AWS provider for Terraform. By including this block, Terraform understands which provider to use and where to create resources in the code. However, as we observed, creating an EC2 instance on AWS required logging to AWS first. We usually do this manually using a user ID and password through the AWS console. But how will Terraform login? This can be achieved by configuring authentication settings. To understand how to do this, refer to the provider's documentation. After that, look for authentication and configuration, where you will find 6 different ways to authenticate AWS using Terraform. One of these methods is parameters in the provider's configuration, where we can pass the user's access key and secret key in the provider block to allow Terraform to log in. However, keep in mind that we don't have access to these keys directly. In AWS, there are 2 ways to log in. First is using user ID and password, just like how we log into the AWS UI console manually. The second is using the access key and secret key, which can be done through the command line, and you can create them for each user. If you remember in the last video, we created a Terraform user on AWS. So now let's go to the Terraform user and generate the access key and secret key for it. To do that, you need to search for IAM and go to users. Then click on the Terraform user. Here you should find security credentials and below that you will see access key. To create an access key, click on create access key. It will ask you about your use case and you can choose accordingly. For now, let's choose the first option for CLI, and after providing the confirmation, click on the next. If you want to add a description, you can do so, but for now, click on create access key. Your access key and secret key will be generated. You can copy them from here and download the CSV file. By the way, let me tell you that these access key and secret key are very important. As we gave admin access to the Terraform user, with this access key and secret key, you can perform all the admin tasks on AWS. So never share your access key and secret key with anyone. Otherwise, someone could use them to provision resources on your AWS account. Now that we have obtained our access key and secret key, let's copy it and paste it into the provider block. Here you can see that besides the access key and secret key, there is also the region field. The region refers to the AWS region in which you want to create all your resources. If you check on the console, you will see that the instance we manually created is in the North Virginia region. There are many regions where you can create resources. Regions are location where data centers are located, and your resources will be provisioned in those data centers. The choice of the region depends on the requirement. For example, if you have a client in Europe, you would deploy resources in the nearest region. So you would choose a Europe-based region. And the price of the resources also varies depending on the region. For now, we will stick with North Virginia and specify it in Terraform as US East 1 in the region field of the provider block. So until now, we have only told Terraform that we want to create resources on AWS in the US East 1 region. Now comes the part of what to create. As we want to create an EC2 instance on AWS Cloud, what is the syntax for that and how do we pass the necessary details? To see this, let's go back to the documentation. As we want to create an EC2 instance, we can filter it out here in the docs. Let's write EC2 instance here. A bit below you will see EC2, Elastic Compute Cloud, in the resources section. Click on AWS instance and in the examples you will see how to write it in Terraform. Let's copy it once and go through it to understand it properly. First of all, in any provider, you can use the resource block to create something. As this is the resource block for creating an AWS instance, it will create an instance on AWS for us. Now, let's focus on the syntax. You will notice three things here: resource, AWS instance, and web. The resource keyword indicates that we want to create a resource. AWS instance shows that we want to create an instance on AWS. Lastly, web is the local name for this particularly AWS instance resource. It is used by Terraform so that it can understand that we are referring to an AWS instance. I want to clarify that web is not the name of the instance. We will see how to name the instance later. If, for example, I want to create two instances, I can use this resource block twice, but the local name for the both instances will be different. So I hope you now understand that web is a local name for better references and understanding in Terraform. This is necessary because many viewers find local names confusing, so it was essential to understand this. Inside the resource block, we have AMI, which stands for Amazon Machine Image. It is the image of the operating system we used in manually created EC2 instance, which was Ubuntu. Here we need to provide the ID of that operating system image. For the ID, you can find it here under Launch Instances in the North Virginia region for the Ubuntu image. Let's copy it from here and paste it into the AMI field in the resource block. Next is instance type. Since we are using a free tier account, we will choose T2 Micro. If you can check on the UI, you will see that the T2 Micro is eligible for the free tier. After that, we have tags where we specify the name tag, which is the name we want to give to the instance. You can provide any name you want. In the manually created instance, we used manual underscore EC2. So here, let's name it Terraform underscore EC2. This code is sufficient to create an EC2 instance. We will cover other configuration step by step in the upcoming videos. The code related part is now complete. Now it's time to run the Terraform command and create the EC2 instance using Terraform. Since the video has become quite lengthy, we will cover the creation part in the next video. You can follow the instruction given so far. If you don't understand anything, you can watch the video again and let us know in the comment section. If you liked the video, please like, share and subscribe to the channel. If you want the notes or PPT of this video, you can join our membership and become a part of the DevOps Pro community. So let's end up this video here, and I will see you in the next video. Thank you.